In section 13.1, we're looking at an introduction to factoring. Consider the product 3 times 5 equals 15. We see that 3 and 5 are factors of 15, and that 3 times 5 is a factorization of 15. Since 15 equals 15 times 1, we also know that 15 and 1 are factors, and that 15 times 1 is a factorization of 15. The greatest of the common factors is called the greatest common factor, or the GCF. We can find the GCF of a set of numbers using prime factorizations. So we're going to utilize factor trees. So let's look at 20 first. So 20 can be broken into, we can say 2 and 10. It doesn't matter what pair you pick because when we're done, we'll get the same answer. And so 2 is prime. We can't break that down anymore, but we can break down 10, and we end up getting 2 times 5, and both of those are prime. Now we want to look at 30. We're going to break this down. This is 3 and 10. Well, 3 is prime, and 10 can be broken down into 2 and 5, which again, those are both prime as well. So we can write 20, and we just take the numbers at the end of the branches. So 2 times 2 times 5. And 30 is 3 times 2 times 5, or you can write that in order, it doesn't matter. And we want to see what they have in common because it's the common factor of both of them. So between both, they share a 2 and they share a 5. And so that means that the GCF of 20 and 30 is 2 times 5, or we get 10. Let's try another one with 3 factors, or 3 numbers. So let's break down 54. Well, 54 is 6 and 9, and 6 can be broken down 2 and 3, and 9 is 3 and 3, and all of those are prime. Let's look at 90. Well, 90 can be broken down into 9 and 10, and we can break 9 down as 3 and 3, and 10 is 2 and 5, and all of those are prime. And let's break down 252. That's 2 and 126. Well, 2 is prime, but we can break down 126 into 2 and 63. And 63 can be broken down into 3 and 21. And then 21 can be broken down one more time into 3 and 7. So let's go ahead and write these out. For 54, we have 2 times 3 times 3 times 3. Or we could write this shorthand as 2 times 3 cubed. We have 90, which is 2 times 3 times 3 times 5. Or we can write 2 times 3 squared times 5. And we have 252, which is 2 times 2 times 3 times 3 times 7. Or we have 2 squared times 3 squared times 7. And so we want to see what these have in common. Well, across the board, they all have a 2 in common. They also have a 3 in common. And another 3 in common. And that's it. And so the GCF is 2 times 3 times 3, which gives me 18. To factor a polynomial is to express it as a product. A factor of a polynomial p is a polynomial that can be used to express p as a product. A factorization of a polynomial is an expression that names that polynomial as a product. So we want to find the GCF of 15x to the 5th, negative 12x to the 4th, 27x cubed, and negative 3x squared. So this works the same way that we just did the other two problems, except we're going to add in some letters now. But we still need to figure out what the greatest common factor is with the numbers, and then we can look at the letters. So let's look at 15x to the 5th. Well, 15, that's 3 and 5, and both of those are prime. And so we can write 15x to the 5th is 3 times 5. And then we have 5 x's, because that's what x to the 5th means. Let's look at negative 12x to the 4th. Don't worry about the negative too much until the end. So let's just pretend we're looking at 12. That's 2 and 6. And we got 2 being prime. And then we have 6 being 2 and 3. And both of those are prime. And so the only thing we're going to add out front of our numbers here is a negative 1 times 2 times 2 times 3. And then we have 4 x's. Let's look at 27x cubed. 27 is 3 and 9. And then 9 can be broken down into 3 and 3. So we end up getting 3 times 3 times 3 times x times x times x. And we have one more. And it's pretty simple because 3 is prime. So negative 3x squared. Well, that can just be written as negative 1 times 3 times x times x. And so now we want to see what they have in common. Well, they each have 1 3 in common. And how many x's do they have in common? Well, they have to have 2 because that's the smallest exponent on the x's. And so that means that the GCF between all 4 of these terms is going to be 3x squared. Let's go ahead and try another example that's very similar to the one we just did. This time we have two different variables going on, but it's going to work the exact same way. I have 14p squared y cubed. Well, 14 is just 2 and 7, and both of those are prime. So what we end up having is 2 times 7. We're going to have 2 p's, and then we're going to have 3 y's. What about negative 8py squared? So again, just leave the negative for the end, and we'll put that negative 1 out front. But 8 can be broken down as 2 and 4. And then 4 can be broken down as 2 and 2. So we get negative 1 times 2 times 2 times 2 times p times y times y. For 2py, 2 is prime, so I can't write this down any honestly simpler than what I have. So what I end up getting is 2 times p times y, just so it's in the same kind of format as the other ones. And then 4p cubed. 4 we can break down just a little bit as 2 and 2. And so we end up getting 2 times 2, and then we have 3 p's. And we want to see what these have in common. So all of them have a 2. And we can't have any other numbers because our smallest one here was 2. So now looking at the letters, we can't use y because not all 4 terms have a y involved, but we can use p. They all have at least one p in common. And that's it. And so our GCF is 2 times p, or just 2p. So to find the GCF of 2 or more monomials, you'll find the prime factorization of the coefficients, including negative 1 as a factor, if any of the coefficients are negative. You'll determine the greatest positive common factor of the coefficients. If the coefficients have no prime factors in common, then the GCF of the coefficient is 1. You will determine the greatest common factor of the powers of any variables. If any variable appears as a factor of all the monomials included as a factor, using the smallest exponent of the variable. If none occurs in all the monomials, then the GCF of the variables is 1, and then the GCF of the entire monomial is just the product of steps 2 and 3. So to factor, we express a polynomial as a product using the distributive laws in reverse. So as a reminder, we've been looking at the right-hand side, and we would distribute the a to both pieces. But now what we're doing is we're looking at the left-hand side and turning it into the right-hand side. So if you look at these two individually, you could say they both have an a in common, and so you could pull that out front, and whatever is not circled would stay inside the parentheses, because this is their GCF. So let's go ahead and try one. We have 7x squared plus 14. So I'm going to write this out the long way. Well, 7x squared, that's just 7 times x and we can write 14 as 2 times 7. You could do the factor trees if you want to, but what these both have in common is the 7. And so we can pull the 7 out front, and then whatever's left over is what stays in x plus 2, but this can just be written as 7 times x squared plus 2. Let's go ahead and try another one. 16x cubed plus 20x squared. So what does 16 and 20 have in common? They both have a 4. So let's rewrite them with a 4. What variable do they have in common? Am I going to pull out x cubed or x squared? Remember that you always want to go with the smallest exponent that's there, so we want to go with x squared. So I'm going to rewrite 16x cubed using a 4x squared. So 4x squared times 4x would give me 16x cubed, and 4x squared times 5 would give me 20x squared. And so again, what is the 4x squared, and then on the inside we have whatever's left over, which is 4x plus 5. And that's your final answer. Let's look at something a little bit longer. 15x to the 5th minus 12x to the 4th plus 27x cubed minus 3x squared. What do they all have in common number-wise between 15, 12, 27, and 3? Well, I could pull a 3 out. And what about variables? Well, again, it's the smallest exponent that's there, which is x squared. So we can pull out a 3x squared out of all of the pieces. So 3x squared times 5x to the 3rd would give me 15x to the 5th. We have 3x squared times 4x squared, which would give me that 12x to the 4th. We'll have 3x squared times 9x to give me 27x cubed. And then we have 3x squared, and we want to have negative 3x squared, so that's going to be a negative 1. So again, what they all have in common is what gets pulled out front. So our 3x squared comes out front, and everything else goes inside the parentheses, including the signs. 5x cubed minus 4x squared plus 9x minus 1. Let's go ahead and try another one. 14p squared y cubed minus 8py squared plus 2py. So number-wise, between 14, 8, and 2, the biggest thing I can pull out is a 2. And what about variables? Let's look at p first. I have p squared, p, and p. So smallest exponent is a p. And then for y, I have y cubed, y squared, and y. So the smallest exponent is just y. So we can pull out a 2py from each one. So let's go ahead and rewrite it. 2py times 7p y squared would give me 14p squared y cubed. And remember, when we multiply with the same base, we add the exponents. We can pull out a 2py from the second one. And so this would end up being 4y because we already have the p. And then the important part here is if the GCF is the same as the term like it is this third one, we have to always put a placeholder of 1, because if we were to distribute it back out, then we would have nothing to distribute it to. And that's the part most people forget. So we put the 2py out front, and we end up with 7py squared minus 4y plus 1. And again, if you're ever not sure, you can always distribute this back out. So distributing the 2py to each piece, and you should get the original. And so the first type of factoring method we're going to look at is factoring by grouping. We tend to use this if we have 4 terms. Certain polynomials with 4 terms can be factored using a method called factoring by grouping. And so example number 5 is already set up to use factoring by grouping, because if we were to look at our 2 separate terms, and remember that terms are just whatever is outside the plus or minus signs, what do these 2 terms have in common? Well, they both have this x plus 1 in common. So what do you think I can pull out of both of these? I can pull out that x plus 1, and then whatever's left over is what goes in the next set of parentheses. So out of the first term, I would have an x squared left over, and out of the second one, I would have a 2 left over. And that's your final answer. X plus 1 times x squared plus 2. Now, most of the time, it's not set up for us to do this automatically. So we have to set it up that way. So let's consider the 4-term polynomial, x cubed plus x squared plus 2x plus 2. There is no factor other than 1 that is common to all 4 of the terms. However, we can split this down the middle and look at the 2 terms separately. We'll look at x cubed plus x squared, and then we'll look at 2x plus 2. Now, looking at x cubed plus x squared, the GCF is x squared. And so when I pull that out, I'm left with x plus 1. In order for factoring by grouping to work, I need to have x plus 1 in the second set we look at. So if I have x plus 1, the piece that has to go up front is a 2, because I need to have 2x plus 2 as my answer. When we group the terms as shown above and factor out each polynomial separately, we see that x plus 1 appears in both factorizations. Thus, we can factor out the common binomial factor, x plus 1, which goes up front because that's what they had in common, and then whatever's left over is what goes in the second set of parentheses. And this method of factoring is called factoring by grouping. Not all polynomials with 4 terms can be factored by grouping, but it does give us a method to try. So let's go ahead and try this with example number 6. We have 6x cubed minus 9x squared plus 4x minus 6. So the first thing we want to do is we split this polynomial right down the middle. So looking at 6x cubed minus 9x squared, what is the GCF? I can pull a 3 out of both pieces, and I can pull an x squared out. So I'm going to pull 3x squared out, and then what I have left over is 2x minus 3. And for factoring by grouping to work, I have to have 2x minus 3 on the other side. So I'm going to copy and paste it, and I have to figure out what goes out front so that when I were to distribute it back in, I should end up with 4x minus 6. So this tends to be a pretty easy thing to find. 2 times 2x would give me 4x, and 2 times negative 3 gives me that negative 6. So what these two things have in common is that 2x minus 3, because it appears on both sides. And then what's ever left over, 3x squared plus 2, goes in the next set of parentheses. And that's your final answer. Let's try another one. We have x cubed plus x squared plus x plus 1. We're going to split this right down the middle and then look at the first two pieces. What is the GCF? Well, the GCF is going to be x squared, and what I have left over is x plus 1. I again want to copy and paste my x plus 1 to the other side because it won't work without that. And then I figure out what goes out front. Now x plus 1 is the exact same thing as what's on the right hand side of our dotted line. So we would just be putting a plus 1 because when I I distribute that, I get the same answer. So I have my x plus 1 in common. And then whatever's left over, x squared plus 1, goes in the other set. Let's go ahead and try another one. We have 12x to the 5th plus 20x squared minus 21x cubed plus 5. So we want to go ahead and split this right on down the middle. And let's look at the first two terms. What is the GCF? Between 12 and 20, I can pull a 4 out. And then the smallest exponent is a 2, so a 4x squared. What I have left over is 3x cubed plus 5. And then remember, I have to copy and paste my 3x cubed plus 5 to the other side. So what do I need to put out front so that when I distribute, I get negative 21x cubed minus 35? And that's going to be a minus 7. And so what do they have in common? They have 3x cubed plus 5 in common. And then what's left over is 4x squared minus 7. And let's go ahead and try another one. We have x cubed plus x squared plus 2x minus 2. We want to go ahead and split this down the middle. Between the first two terms, we can pull out an x squared. And what I'm left with is x plus 1. For this to work, we have to copy and paste x plus 1 on the other side. And then what do I have to put up front so that when I distribute, I get 2x minus 2? Well, if you wanted to put a 2 up front, when I distribute it out, I would end up with 2x plus 2, which is not the original. And if I put a negative 2 up front, I would get negative 2x minus 2. So there is nothing that I can do, so this could be factored by grouping. It might be factorable in general, but it's not by this method. So this is not factorable by grouping. And so some last tips for factoring is before doing any other kind of factoring, you always want to see if you can factor out a GCF. This is the step that most people forget to do. So before you attempt whatever method you choose, you always want to try and factor out the GCF first. You can always check the result of your factoring by just multiplying it out, and you should get the original polynomial.